I thought this was going to be in the afternoon. So, good morning. My name is Mark Buchanan. I am a conservation specialist with the Conservation Agency. We're going to be doing a rain barrel workshop here this morning, and I was kind of kidding around with folks, but there's a lot of truth to it too. But we had to have this PowerPoint along with it, because if we were just cutting in 3 holes in a barrel, we'd be done in like 5 minutes. So I'm kind of try to lengthen it out a little bit. I'm going to give you a little bit of information about method to the madness, why we as conservationists and natural resource professionals are concerned about harvesting rainwater. At least, it's a means to an end, I guess we could say. It's a pretty important endeavor. I'll start off, and I'm going to go over some real basic stuff with some really basic hydrology. Look at different types of collection systems, and then we'll go in and we'll put one of these together. And like I said, it's extremely easy, very easy. If you can run a drill, then you can put it together. This kit, and everybody that signed up for the class will get one of these kits. It's from an outfit called Earth Minded, and if I move too fast through the instructions on how to put this thing together, well, all you got to do is open up the instructions, and you'll probably get a better version than what I'm giving you. So, nonetheless, everything is kind of compact and together. In the past, we did presentations down in the city of Huntington when they first kind of started getting into their stormwater issues, and we started working with the city. We did multiple stormwater classes, I guess you said, where we built some rain barrels, and we were pulling in pieces, plumbing parts and stuff. And you send somebody to Lowe's with a list, a 3/4 inch male end versus a 3/4 inch female, and you've got people, at the end of the thing like, yeah, thanks a lot, buddy, and just walking off, because it's just too much. This, on the other hand, this kit, it's like I said, it's got absolutely everything. You won't have to have anything but a drill, maybe a screwdriver. I mean, seriously, it's got all of the small parts you'll need, even the hole saws. It comes with 3 hole saws with the 3 appropriate sizes to drill the barrel and your downspout too. It comes with absolutely everything. Even a nifty sticker to remind you not to drink the water out of the barrel. So that's really important stuff. No offense, but there's been some lawyers involved with this.
Offense taken. I don't need a label telling me not to drink out of it.
All right, with that said, we'll go ahead and get moving. When I start this presentation, a lot of times, I don't know what kind of audience I'm going to end up with. Sometimes I end up with people who are really in tune with this kind of topic. Most of the time I end up with folks who aren't in tune with this kind of topic. So I'm going to give you a little bit of background information. When we start talking about urban hydrology, what I always like to try to bring up is picture where we're at right now, or maybe if you live in Charleston, picture Charleston or Huntington or wherever, insert small town here, whatever. 250 years ago, 300 years ago, whatever. Looks a lot different. It would look a lot different than it does today. The main difference, the biggest difference, would be the amount of impervious surface that you have in that drainage area. When you have development, inevitably you get roads, paved parking lots, roofs on buildings, houses, whatever. All of those shed water. It's just part of what happens. It's nature. But what happens is you move an awful lot of water into a stream faster than it can really be absorbed. And we'll explain it in just a little bit. So when you have urban hydrology versus native, you end up with greater runoff, what we call flashy stream. In other words, if you have an urbanized area like in Charleston, any stream that would happen to run through Charleston, you get an inch of rain, that stream's going to jump up really quick and flood. Sometimes flood, not always. It just depends on the amount of rain, right? You get the water jumping up really fast, but it also goes down quickly too. It's a flashy stream. That's what we call it. Other issues, you have increased erosion potential within stream channels, lower storage in soils, and low groundwater recharge. And the reason we're in this is because of the degraded potential, or the potential for degraded water quality. And ultimately, that's as far as the program that PAM runs, we're part of the state's non-point source pollution program, I guess we could say. We handle the agriculture and some of the stormwater stuff now, although officially it's not, I guess, in writing, but nonetheless we've been helping a lot of municipalities with stormwater type issues. And I'll throw this in here to put you to sleep. What you have here is a graph. Across the x-axis is time, and on the y-axis, stream flow rate, or I like to think of it as volume. You have two curves here. You've got conditions right here. This is showing the volume of the stream prior to any type of development. As you move across, you have our nice little rainstorm here. You expect an increase in volume within the channel. Peaks right here, and then you have a nice gradual recession back down to the base flow. In an urbanized setting, just like I talked about, you have a lot of impervious surface, impervious, the roofs, concrete, parking lots. You end up with a really fast spike, a really high discharge in a short amount of time. It wreaks havoc on the stream and water quality in general. And, it's just the way things are, and I'm not going to blame any engineers. Nonetheless, we always, when architects and engineers would put designs together for buildings, the main thing was to get the water away from the foundation as quickly as possible. So that's what we did. And this is your result as far as, there was not a lot of attention paid to what goes on around the building, big picture type stuff. So you end up with this. So, we start talking about, when you have this type of setup, you end up with, some effects. There are some effects to what goes on here. You've got, increased potential for flooding. Everybody's favorite within our agency, stream bank erosion. An increase in turbidity, and turbidity is when you measure how much sediment's actually suspended in the water. And the turbidity indirectly leads to habitat destruction. And, what happens is we have those increased bed loads, and it's too much for that stream to actually handle. The stream actually can be changed, morphed into a different type of stream. You also end up burying a lot of benthic macroinvertebrate habitat, and those are just basically critters that spend part of their life cycle in that stream at the beginning of the food chain. So if you end up wiping these guys out, you basically get rid of your bass and your desired species of game fish, which can be an issue. Then there's other issues associated with these peak discharges, high peak discharges. Changes in stream flow, like I said, and that's because of point bars and things that end up forming. The stream abandons the floodplain. CSOs, and that's an issue in Charleston as well as Huntington, these larger municipalities, Parkersburg. Infrastructure damage, and then the big one is contaminated streams, rivers. And I was at a conference last week, and somebody asked me, well, why would we be concerned with coastal water? Well, we are in part of the state is in the Chesapeake Bay's watershed. The majority of the state lies within the Gulf of Mexico's drainage. In other words, all the water that comes from these rivers around here ultimately will make its way down to the Gulf of Mexico. And there's an area in the Gulf of Mexico that's so contaminated with excessive nutrients, it's a dead zone. It's about the size of the state of Connecticut, and the fishing industry is in a panic, because it's a dead zone. The nutrients and stuff that end up in the water actually causes the algae to grow, and as the algae starts to grow, it gets kind of rampant. Well, it dies. When it dies, the bacteria start to break it down, but use the oxygen that's suspended in the water. It's like a domino effect. And you end up with these huge areas. It's called a hypoxia. You have these hypoxic regions of the Gulf where there's no fish or game, or sport fish, or commercial fishing too. So it's a serious issue. I think there's more of a grasp on the Chesapeake Bay now. I'm speaking something about the Chesapeake Bay, and I don't know a whole lot about it. But at least there's a grasp on the Chesapeake Bay. And I keep looking at Pam because Pam runs those programs. So if I'm wrong, feel free to correct me. But the Gulf Initiative and those kind of things are just down the street from what it looks like. There's going to be probably a big push here about watershed science, especially when it comes to ag, because ag, we usually get blamed for it. I don't agree with all of it. We can have a discussion after a while if you want to. But how do we manage this kind of stuff? How do we manage this excessive runoff and keep that peak or lower that peak and have something that's a little more natural? It's not rocket science. We try to hold back as much as we can. We do that, and luckily within our program, Pam, she's kind enough to, she puts money down in our conservation district, and we get with conservation districts, we get to do like demo projects that concentrate on bioretention cells, putting riparian buffers in it. And a riparian buffer is basically just the wooded area along the stream. And real basic things like this can make a huge, huge impact, positive impact. Stormwater planters, rain barrels is on, yeah, rain barrels and cisterns. And yeah, I've been accused by a couple of engineers in our offices or NRCS partners, you know, here goes Mark with his barrels trying to save the world 50 gallons at a time. I'm not stupid. I know that we're not going to offset enough of a peak discharge here to make a difference. This is a conversation starter, is all this is. This begins the conversation to talk about it, to understand the concept. That's where we're at with this. So with that being said, you know, rain barrels and cisterns, two good ways to kind of capture and use rainwater. So and speaking of rainwater and using rainwater, again, not rocket science, it's been around. And you guys work with farmers just like we do. And, you know, they're very resourceful. You know, I've been on several farms and, you know, I always marvel at how resourceful these ladies and gentlemen are. This is a really old setup here. He's got his gutter running along, and basically the water spills down here. You can see where these pails are, where he's kind of carried it, or she, either out to the flowers or the fields. These things can be very, very simple to the very, very elaborate as far as the rainwater collection system. Here you've got something like what we're going to do, which is just a really basic. All we're doing is trying to capture, you know, runoff off of a residential household. You know, I don't know what kind of sadist thought of this, but I couldn't imagine trying to do the plumbing on that. This picture, I had an intern that worked with me a couple of years ago. That's horrible. I can't think of her name right this. And we were contacted by a school over in Wayne County. They wanted to do a rain barrel, except they wanted to do something a little more elaborate. And Jessica, the intern, came up with this, and I shot it down almost immediately because I saw a lot of risk on our part for taking part in something like this as far as a project, because who knows if it would even work. But the point I was trying to make, from the simple to the more elaborate to even more elaborate of an actual household system that kind of catches and collects. This goes so far to even have, this is your pump down in the bottom right here, and you've actually got like a float valve here that will, you know, control levels and whatnot. I'm sure there's some sort of treatment system in this, because obviously rainwater is, you know, not exactly clean, especially when it comes off of a roof. You're going to have that at first, what they call the initial flush. You'll have that first initial flush of whatever's on the roof if you have bird droppings. Sometimes you're going to have, you know, asphalt shingles. Could be an issue because you could have some hydrocarbons kind of mixed in there. And I've read some studies that talk about trace amounts of hydrocarbons in that initial first flush. And there's, you know, they'll sell you anything, you know, to answer a question, but nonetheless, there are things that you can put on barrels to capture that first flush. Never tried any of them, so I'll tell you that they're there, but I'm not going to tell you whether they work or not, because I haven't tried them. I don't usually water food product or anything. I just water flowers and wash tools and sometimes a car. And I'll explain how we do that in a minute. So, how much water are we talking when we start talking about a rainstorm? This is, you know, to put things into perspective, I guess. And what I've done is try to figure out like what the average size home was as far as square foot on the roof. About 1,500 square feet turns out is pretty average around the state. If you multiply that area, that square footage off the house by the inches of rain, and you multiply it by 6.23, you'll end up with your total gallons that fall. So if you use this example, 1,500 square feet, inch of rain, 0.623, 934.5 gallons. Now you see why the engineers think I'm a nut, because we're not going to save the world with one barrel. You know, that barrel, this 50-gallon barrel will be filled up in about 30 seconds. The rest of it's overflow. So, again, it's conversation starter. We're not fooling anybody. A lot of water. Some of the uses that you would have with this, the basics: watering landscape plants and lawn, cleaning tools. I was kind of guarded when I say watering vegetable gardens, just because of the hydrocarbon type thing, or the asphalt shingles. I haven't found one definitive study that will say one way or the other, you know. But there's definitely trace amounts of hydrocarbons can be in that first flush. Keep that in mind. I'll let you be the judge. Flushing toilets. The wife's not along with this yet. She's not too keen about me hooking up a rainwater flushing system for the toilet. So If it ever happens, I'll let you know. Benefits. Some of the benefits of using rainwater. The first and most obvious, it's free. No charge. I don't know if any of you guys with city water, usually if you're watering your garden, they base your sewage bill off of your water usage, which is not fair because you're not, not all that water is going to be rushing down the sewer, but you still get charged for what you use. So it's free. Rainwater is softer. By this, we're talking pH. The pH is just below 7, around 6-ish, around our part of the state. Anything above that, 7 and above is considered hard or more alkaline, a lot of minerals dissolved in it. You'll end up with, the scale and stuff that you have, some faucet handles and stuff. That's because of issues with the pH, usually being too high. Rainwater is softer, which some say is better for plants. Again, no minerals. No chlorine, supposedly better for your plants. And of course, environmental benefits that I've been tallying up here. And when you get one of these, you got to set it up, and there's going to be a couple of ways that you can put this faucet on. And I like to put the faucet as low down on there as I possibly can, so I can have more water for my use. And that means I have to kind of set that up on a pedestal, whether it be cinder blocks or maybe a nice block foundation. All I want you to know is if you do that, it's heavy, and make sure it's stable, because if that thing tips over onto a small child, don't come calling me, It's like, water's heavy, and I think I've got a note on here somewhere, 8 pounds to a gallon. So if you get 50 gallons of water, 400 pounds, that's a big boy sitting there. And if it tips over, it can do some real damage. It could probably tear down your gutter, you squish a kid, dog, cat, whatever, nonetheless. Again, here we go. Do not use as drinking water. I'm not going to go too much into that. And it should be stored for extended amounts of time. So what's an extended amount of time? More than a week. We'll just throw that out there, and it's going to vary plus or minus a little bit here or there. A lot of these, this one kind of touts. It doesn't say that it's mosquito proof. I've never seen anything proof anything. It's like 100% guaranteed, for whatever it is that we're selling. But if I was a betting man, I'll put my money on this would be the closest thing that you could have to something that's mosquito proof. Just the way the system's set up, it's not open. The overflow, a lot of times when you have an overflow, the mosquitoes will get in through the overflow. You can't on this one. And the barrel is sealed on top. So it is pretty tight. I'm going to stop with saying mosquito proof, I won't say that. Nature always finds a way. Another thing you might want to be concerned with, don't store it for extended amounts of time, especially when the weather turns cold, like we're getting ready to go into right now. We're getting to November and the nights are really starting to get down to those freezing points and stuff. If you have any water in the barrel, you run a really good risk of busting the barrel, with the expansion when it freezes. But the way these things are put together in a factory, and you can see the seam. The two sides are molded separately, and then they're basically welded together. So this is a weak point, all up and down, up, chip it, up one side and up the other side too. So if you have that freeze and thawing cycle, you can actually push it to the point where it actually split. And I've left mine out all winter and haven't had any issues, but you're rolling the dice when you let it sit out. Sometimes I'm just too lazy to get it taken off the downspout and remove them for the winter season. So that's what we're talking about there.
Can we go back to the cleaning?
Oh yeah, sorry. Clean the barrel once or twice a month, especially during the summer. Obviously you're going to have them down in the winter anyway, but probably every 6 weeks would probably be sufficient. Usually the ones we've done in the past, we've used a white barrel, and even though it's thick enough you think it would be opaque, you'd be surprised at the amount of the algae and stuff that forms on the inside of the barrel. This is nice because you can unscrew the top and clean it out for maintenance. I usually a little bit of Dawn detergent or something like that. Dish detergent's going to be absolutely fine. Take a hose and spray it and tip it over. All of this green slime will fall out. If you don't clean it, you run the risk of clogging up the plumbing because that slime will actually fall down. And when you turn the water on to use it, it'll actually try to draw that slime out, and the slime will kind of get gunked up into the faucet. It's kind of nasty.
Shouldn't use bleach.
Some people do use bleach, and there's probably no problem with it if you don't have an issue with it. It's not going to kill anything. Just make sure it's diluted.
Yeah.
I wouldn't use it straight, though. Maybe dilute it, like 50% solution or something like that. Would probably be fine. So yeah, definitely if you want to keep them, clean. clean, that's the way to go. I'd say probably 2 times during the whole summer, probably be more than enough. I haven't had any results with these. These, as far as something being opaque, this is probably as close to opaque as we're going to get. I'd be surprised if you had anything growing on the inside, but with the warmer temperatures, you're probably going to run the risk of having that happen, especially in the summer. And this slide, this is an old slide. I should have taken it out. And if you're interested, like I said, this is the all-inclusive package everybody's going to get at the end of the program today. This is one of the builds that the intern I had working with me a couple years ago came together with. It's pretty nice. Using one of the sealed top barrels, you basically put the plumbing in the bottom and flip it over, and then this is an overflow. And if you guys have any other barrels at the house, you know that your overflow is really important because 2 inches minimum diameter. This doesn't fall in the same class. I've seen a lot of rain barrels where they'll have like these little tiny 1-inch openings, and if the barrel gets full, it's shooting, 10, 15 yards out into the yard, 10 or 15 feet out into the yard. So yeah, a larger overflow is really important if you're going to do a design like this. And I can get you, if you're interested, I can get you the specs on this design. I think Jamie actually has a copy of that on the Watershed Resource Center. Those are a couple of, I call them bad designs. I've done this for a few years now, and I've noticed and see how things evolve. See how small the overflow is? Not good. This is more like what we're going to be doing today. Like I said, and you'll be, the presentation, 3 holes in the barrel and we're done. It's real simple. The way this overflow works, this little pipe right here is your intake, and it has dual duty. It will actually fill the barrel, and it also serves as an overflow, which sends it back down into your downspout. And I'll show you that in a second too. A few resources if you're interested. If you want to be able to get to some of these sites, if you're really into it, you can contact Pam or the Watershed Resource Center. They can get you a copy of the PowerPoint presentation, which will include this. Okay? Any questions? All right. Let's build us a barrel. We'll build a barrel. Okay. These barrels are all food grade, by the way. Can we move this? The barrels are all food grade and actually came from Greece. They got olives. They carried olives in the barrels. And some of them, when you unscrew the top and you pop this lid off, there's a little rubber ring. If you toss the rubber ring, it's not a big deal. You don't have to have it. As a matter of fact, some of them are falling down in there, and they're very difficult. This one, I use this one as a demo barrel because we dropped it off the truck. It'll eventually pop back out as the sun hits it, nonetheless. So this is our barrel, and yes, they do need to be cleaned up. They're pretty rough looking, got some dirt and whatnot.
They need to be turned over before they load them.
Okay, we had some incidents. What you need to do is make sure it's still got juices, and some of them even have a couple of olives in it.
Olive stuff.
Yeah, it's nothing bad. It's just a little bit of olives. It doesn't smell bad. It actually smells kind of good, but I don't like the taste of olive. All right, so I'm going to go ahead and put this on just for the sake of having it on. And like I said, you open up this kit, you're going to have a drill bit, and you're also going to have a hole saw. What you're going to do is back this off and put the first hole saw in here, just like so. And let's see. No. I was getting a little worried there. I didn't even think we were going to do this. All right. So get this put in. Like I said, all you need to drill. And like I said, you're going to put this somewhere near the bottom with a minimum of 3 inches. Well, this is more than 3 inches, and I would not put it on its sloping face. We might be forced to kind of have it up a little bit higher than we like if you get a barrel like this. Some of the barrels have these ribs up through them just like that, and some of them are more smooth. So a little bit of variation nonetheless. If you get one like this, I would definitely try to stay as close to that flat face as I could to prevent the risk of leaking. I'm also going to try to stay away from that seam, up one side, down the other. So I'm going to go ahead and punch this in. Torque it down a little bit. There we go. going to be for our faucet. The next hole that you're going to put in is for a drain. And if you wanted to put it on the bottom, you could. I wouldn't recommend it just because it might end up leaking on you. And I'm going to go against what I just said a while ago. I'm going to go ahead and put it on the face of this, right down here. And it's up to you. Wherever you want to drain it, it is absolutely fine. I'm going to go ahead and put it in here. All right, once you get those two holes drilled, you've got two little plungers, or two seals that are going to fit in here. And it's a tight fit because it's going to be watertight. So if you have trouble, if you take a little detergent soap, dishwashing soap, it should go right in. Or I guess you could dip it in a little bit of olive oil if you wanted to. Shouldn't have any problem with that. There, popped right in, just easy as pie. All right, now we're going to. This is for our drain. Stick that one in.
Are they the same size?
They're exactly the same size. And watch me not be able to put them in after I said that.
You just make it look easy.
Yeah. You'd think as many of these I put together, I'd be able to do it. Okay, here we go. So both are in now, just like that. Faucet, not exactly of the greatest material, but it's plastic and it'll work. It'll serve the purpose. Somebody asked if you'd have to put the plumber's tape on the threads. No, there's no need. If you want, you can. If it makes you feel better, knock yourself out. All right. You might have to hold it as you turn it to make sure it sits. Just like so. Now we've got our barrel faucet. This is going to be our drain. So as we get late into the fall and we're done with the gardening season, we can come in and drain it just by opening this up.
Why wouldn't you just use the faucet as the drain?
Because I'm going to have about a foot of water stored up in here.
Put
See?
the faucet,
Huh?
not to put the faucet.
Well, you could, like I was saying, in some barrels you can. If you do decide to put your faucet down further, and you make sure that you know that you're going to have to put it on a pedestal because you're not going to be able to put a hose under there. So keep that in mind. Of course, I'm going to have to get in there because of the bits in it. Set that down. Hey, Jay. Now we got one more hole to drill. We'll be done. Set up. Gee whiz. Here it goes. We'll go get this off. Usually it's not this hard, we're having a little bit of trouble with it. But we have to get this hole saw off and put the next size up. This hole saw is right at it's 1.25 inches. The next one is going to be 1.5 inches. Gotta be kidding me. You never know what you're going to get here. There it goes. Okay. And it comes off just that easy. I mean, just that easy. Gee whiz. All right, now we're going to put the 1.5 inches on and punch it through. Maybe if I can figure out how to work it. And this is where we're going to put our intake. Get that nut back on the back side. Just like so. All right, here we go. That didn't take long at all.
Are those included in the kit, Mark?
Yes, all of the hole saws are included in the kit. All right. I'm going to make a hole for this little attachment here. This is just the rubber seal. I'm going to come, and if you want it on the side, you can, because this actually can extend out over 2 feet. So, keep that in mind. I like to put, I usually set my barrels up to something like this, right directly in front of it. So I usually put it back directly opposite the side of the faucet. So we go ahead and punch this in here. This step is kind of important. Let me get the holder in. I'm going to try to get it on as flat a face as I can. Okay. Just like that. Push that out. Done with that one. And then you come, this is going to be the one that you drill a hole for the into your downspout. And this is actually 2 1/8. So keep that in mind. This one's set up. Alright. Last hole we just did, I'm going to punch this through just like that. This is where the hoses will end up going into. And again, I don't like it. Keep it shorter. And it's pretty snug. This, by chance, has a little bit of olive oil on it, so it worked pretty good. So, now that this is the thing that probably made somebody rich. Remember I said you don't have two separate, you don't have an intake and an overflow, it's one and the same. This is what this is, and this goes into, you take that hole saw that we just used, that 2 1/8, and you punch into your downspout, just like that. Actually, it's going to be a little bit higher, this is from another demonstration. So you're going to punch a hole, and this is going to fit right into here, just like so. And what happens is, as the water falls down, that cut catches it and diverts it into the hose. It's pretty slick how it works. And and the biggest, the most important cut that you will make is in the downspout. You don't want to get it too high. If you have it like this, what's going to happen is it's not going to be able to function as an overflow, because the water will fill up and it'll only be able to make it up that pipe so far, so the water will continue rising in your barrel and come out over the top. If you have it too low, like this, it's not going to fill your barrel up. Okay, I don't know if you guys can see that in the back. It won't be able to fill your barrel up if you've got it too low. So, the just right Goldilocks spot is right about a difference of about a 1/2 inch in elevation from your downspout to the barrel. Keep that in mind. Now, it'll be in the instructions, okay? Just read those instructions, but this is the most important cut right here. Make sure you don't have it too high or too low, or otherwise it's not going to function like they designed it to. So, once you get it all hooked up, you should be good to go. Make sure if you are going to have that set up, that you come, okay, let's do this. Let's say November, end of November rolls around, you want to take everything down, just come in, pop this out, take it in the garage. You're going to be inserting this little guy here, and this will actually cover that for the winter. Just like that. You got 2 screws, you punch the 2 screws in, you carry the barrel in the garage, put it in the corner somewhere, and let it sit through the winter. Then April comes around, roll back out and set everything back up. So it's pretty, like I said, it's got everything you absolutely need. Pretty convenient. I feel like I'm a salesman for these guys. But nonetheless, it's a whole lot easier than what we were doing earlier. You've got the 2 little machine screws, so keep track of those. But other than that, that's pretty much it. You'll be able to collect probably, on average, 50, 55 gallons of water per event. And like I said before, it doesn't take much to fill them up. Probably on a decent rainfall, it'll be filled in less than a minute. And the rest is overflow. So, any questions?
Is the 1/2 inch or so that you punch into your downspout above?
Above, yes ma'am.
Okay.
It'll be about a 1/2 inch just above. And if you don't get right at a 1/2 inch, I mean, you don't have to get any survey equipment out and level it up. But if you get it,
I'm gonna take
just
measure.
ballpark, just make sure that it's close. You can almost eyeball it and tell. If it looks too steep, it probably is, and it's not going to be able to discharge any overflow.
And the direction that little thing goes in the downspout?
Yes. And keep a hold of these. This is instructions that come with it, and it's got absolutely everything that you would need. Any questions? Oh wait, and the most important are all your friends. don't drink the water. Okay?
Or,
That's all I got.
or do,
Or do if you want.
but you've been warned.
You've been warned, yeah. Huh? Did everybody get,